In the vast stillness of space, where light takes millions of years just to reach a single thought, something has begun to move. They call it 3I Atlas, an interstellar wanderer, once thought to be nothing more than a drifting shard of ice and metal. But in October 2025, it did the impossible. Its size doubled within 7 days. Not an illusion, not an error in data. A 23-kilometer object became 46, as if some unseen hand had awakened it from dormancy. Observatories fell silent, equations lost meaning. And for the first time in human history, it felt as though the sky was looking back. If you too feel confused, intrigued, or quietly uneasy about what's unfolding out there, stay with me. Because as we uncover the secret of 3I Atlas, we may not just learn about the universe. We may discover the limits of ourselves. If you're as curious as I am, leave a like and subscribe. We'll face this mystery together. For millennia, comets have haunted human imagination. Ancient eyes saw them as omens, serpents of fire that sliced through the heavens, harbingers of war, famine, or divine wrath. But in time, as our telescopes grew sharper and our minds more daring, the superstition gave way to science. We learned that comets were not ghosts or prophecies, but wanderers, relics of the solar system's own infancy, fragments of its cold beginnings. Each comet is, at its heart, a paradox, fragile, yet enduring. It is a body born from dust, ice, and time itself, a frozen archive of the first billion years after the sun ignited. They drift far beyond the planets, exiled to the Oort cloud, a vast halo of ancient debris encircling the solar system like the faint memory of creation. And once in a while, something stirs them from that sleep. A gravitational whisper from Jupiter, a tug from a passing star, and the comet begins its long fall inward. As it plunges closer to the sun, the physics of a comet is, on paper, simple. Solar radiation strikes its frozen surface, heating it just enough for the ices, carbon dioxide, methane, ammonia, water, to sublimate directly from solid to gas. This vapor escapes through cracks in the surface, dragging dust along with it. The result is the familiar sight we know so well. The shimmering tail, the luminous coma, a halo of gas and light stretching for millions of kilometers across the void. And yet in this dazzling display, something quiet but fundamental happens. The comet loses mass. The solid nucleus, that hard frozen heart, gradually erodes. Each pass near the sun shaves it thinner, smaller, weaker. It's a slow death, predictable and poetic. We have never, not once, seen a comet grow. Every observation, every simulation, every equation insists the same thing. The nucleus shrinks. It does not swell. In the language of physics, heat is entropy. Expansion is death. A comet cannot inhale sunlight and become more massive, any more than a melting ice cube can expand while it evaporates. And yet 3I Atlas has done exactly that. To appreciate the impossibility, consider what these laws represent. Thermodynamics, the quiet governor of all motion, dictates that as ice warms, it must melt, vaporize, or dissipate. Matter cannot simply appear. Volume cannot double without cause. Every gram, every photon, every whisper of energy must be accounted for. Our universe is built upon this honesty. The conservation of mass energy, one of the sacred cornerstones of physics, ensures that nothing can arise from nothing. Even the birth of stars obeys it. Nebulae collapse under gravity, fusing hydrogen into helium and light. Matter becomes energy, but it never multiplies itself. And so, when an object like 3I Atlas suddenly grows to twice its size in a week, it is not merely a curiosity, it is an act of defiance against the entire architecture of the cosmos. It's as if the universe itself has blinked, and in that moment, the rules bent. Scientists are not dreamers, at least not officially. When faced with anomalies, they first look for error. Could the measurements be wrong? Could it be an illusion of brightness, a halo of gas misread as a solid body? But the data refuses to yield. Multiple independent observatories across the world, the European Southern Observatory in Chile, NASA's Infrared Telescope Facility in Hawaii, and the Gemini Observatory, all recorded the same result. Different instruments, different wavelengths, different hemispheres, and all pointing toward one truth. A 23-kilometer object had become 46. If this were a mere trick of light, it would have shown inconsistencies in the albedo, the measure of reflectivity. But the light reflected off Atlas did not behave like dust. It bounced as though off solid matter. The spectral signature was sharp, dense, metallic even. This was not a cloud of vapor expanding in the sunlight. This was a structure unfolding. For a moment, let's imagine, not believe, but imagine, that what we are seeing is mechanical. A body designed to travel through the darkness for eons, its surface sealed against radiation and micrometeorites, folded tight like a seed awaiting spring. Then, as it nears the warmth of a star, it opens. Panels unfurl, sensors awaken. A sail extends to capture the photon wind. In human terms, this is plausible. We do it ourselves, though in miniature. The James Webb Space Telescope unfurled an 18-segment mirror the size of a tennis court, its movements timed to millimeters. Our Voyager probes have traveled beyond the heliosphere, their signals faint but deliberate. If humanity, a species barely a whisper in cosmic time, can engineer such precision, why not something older, wiser, born beneath another sun? And yet, this idea terrifies us because it implies intention. And intention requires intelligence. For centuries, the cosmos has been our mirror of constancy. The planets trace their orbits with patient discipline. Stars burn according to the language of fusion. Even chaos follows rules. When something breaks those rules, when the sky itself seems to inhale, it touches something primal within us. A discomfort that predates science. It's the same unease our ancestors felt when they saw comets streak across the sky, believing the gods had exhaled fire. We thought we had outgrown that fear. But now, as we watch 3I Atlas swell like a living thing, that ancient pulse returns. It is tempting to dismiss it, to find comfort in simpler errors, perhaps a calibration issue, perhaps a trick of geometry. But when 3 observatories separated by oceans all tell the same story, denial becomes faith in its own right. And science, at its heart, is not faith. It is courage, the courage to look at something that doesn't make sense and refuse to look away. If the nucleus of Atlas truly expanded, then it is not behaving as ice or rock or even plasma. It is behaving as something else, something capable of transformation without destruction. And that single truth, if verified, could rewrite our textbooks from page 1. There's an irony here. For decades, scientists have sought signs of life by searching for what shrinks, atmospheres thinning, energy fading, entropy spreading. We assume life consumes, deteriorates, expends. But what if the opposite were true? What if the signature of life, or of design, is not decay but growth? When a seed splits, it expands. When an embryo awakens, it swells, multiplying its cells in a geometric rhythm. Growth, in biology, is the first sign of consciousness. So when we witness an object 23 kilometers wide swell to 46 in a week, perhaps we are not witnessing destruction at all. Perhaps, in some unfathomable way, we are witnessing birth. The most haunting part of science is not ignorance, it is silence. Right now, as telescopes aim skyward, we are suspended in that silence. The equations have stopped answering us. And the data, once obedient, now seems to whisper in a language we do not yet understand. It's possible that in time we'll find the mundane explanation. Perhaps there are ices unknown to us, volatile compounds that expand differently under extreme heat. Perhaps the nucleus is hollow, a fragile shell collapsing outward like a dying lung. But until then, the mystery remains. And maybe that's the point. Maybe the universe is reminding us that even after centuries of discovery, we have not yet earned the right to call it ordinary. In the first chapter of this story, we watched the impossible unfold. A celestial body that grew instead of shrank, that dared to breathe against the vacuum. Now, as we revisit what comets are supposed to be, the contrast becomes unbearable. The familiar and the alien have met in the same orbit, and we can no longer tell them apart. And this trembling border between knowledge and wonder, is where the next chapter begins. Because if 3I Atlas is truly not what it seems, then the question is no longer how it behaves, but why. And who, or what, set it in motion. The night of October 12, 2025, was supposed to be unremarkable. Chile's Atacama Desert lay beneath its usual quiet brilliance, the air thin and sharp, stars burning with the kind of clarity that only the driest place on Earth can provide. At the European Southern Observatory, ESO, the instruments hummed in their steady rhythm, turning silently toward an object catalogued as 3I Atlas. one of several interstellar visitors to grace our solar system in recent years. At 2:47 a.m. UTC, a series of high-resolution exposures were taken through multiple filters. Nothing unusual, a faint object moving on a hyperbolic trajectory, gliding between Mars and the Sun. The data was logged, calibrated, and forwarded to Hawaii for correlation. It was only 7 days later, when the same object was measured again, that the world of astronomy found itself staring at something that should not have been possible. Science, at its core, depends on agreement, independent eyes seeing the same truth. On that October week, those eyes belonged to three of humanity's finest machines. 1. The Very Large Telescope, VLT, in Paranal, Chile. 4 massive mirrors, each over 8 meters wide, working in unison like organs of vision carved into the desert. 2. NASA's Infrared Telescope Facility, IRTF, on Mauna Kea, Hawaii. A sentinel watching in wavelengths invisible to human sight, capable of tracing temperature, density, and composition from millions of kilometers away. Number 3. The Gemini Observatory, operating twin telescopes, one in the northern hemisphere, one in the southern, to cross-check every photon that entered their domes. Each facility observed 3I Atlas during that narrow window between October 12th and October 19th. Each used different instrumentation, different calibration protocols, different staff, and yet, all three returned identical conclusions. On October 12th, ESO reported the object's apparent diameter at 23 kilometers, with a margin of error below 2%. A week later, the measurement was repeated, 46 kilometers. Not a subtle change, not a drifting error. A precise, consistent 100% increase across multiple instruments and observation angles. NASA's infrared readings matched perfectly. The energy curve, the way heat radiates from a body into space, followed a pattern that simply could not belong to a diffuse gas cloud. It radiated like a solid object, one with surface emissivity comparable to dense carbon or metal alloys. Gemini's polarimetry data, measuring how light scatters off the surface, revealed something even stranger. The polarization signature had changed in a way consistent with newly exposed reflective material, not with dust or vaporization. The object wasn't shedding matter. It was revealing it. To grasp the magnitude of this event, imagine trying to explain it with ordinary arithmetic. A sphere 23 kilometers across has a volume of roughly 6,000 cubic kilometers. When that sphere doubles in diameter to 46 kilometers, its volume doesn't double. It increases by a factor of 8. That means the total volume of 3I Atlas increased by more than 510,000 cubic kilometers, the equivalent of 7 times the volume of Lake Superior, materializing out of nothing. Nothing, no accretion disk, no cloud of debris nearby, no impact event that could have delivered such mass, no thermal jets pulling in dust. The comet simply grew, and that, by every measure we understand, is impossible. If it were a natural body, this expansion would have required an input of matter and energy exceeding anything short of stellar activity. For a frozen rock hurtling through the void at 200,000 kilometers per hour, there is no mechanism, none, to account for that kind of structural inflation. Unless, of course, the structure itself was never solid to begin with. It was Dr. Avi Loeb from Harvard who first proposed, years earlier, that some interstellar visitors, particularly Oumuamua in 2017, might not be solid rocks at all, but thin, hollow, engineered objects designed to travel vast distances with minimal resistance. At the time, it was a controversial suggestion, quickly dismissed by traditionalists as speculative engineering. But after the Atlas event, that speculation suddenly looked prophetic. If 3I Atlas were hollow, a vast, lightweight shell instead of a dense stone, then its ability to change apparent size might make sense. A hollow structure can expand without gaining mass. Panels could unfold. Frames could articulate. Layers could separate. To our telescopes, such a transformation would look exactly like what we observed, an object doubling in apparent size without increasing its thermal signature proportionally. And indeed, the data showed this subtle clue. Infrared flux, the total energy emitted, rose only 18%, not 800%, as would be expected if the entire mass had doubled. It wasn't gaining material, it was changing shape. Astronomers tend to trust their instruments more than their instincts. But the images from that week shook even the most seasoned among them. ESO's sequence revealed faint linear shadows emerging across the object's northern hemisphere between October 15th and 17th, as though struts or ribs were unfolding, catching the sunlight in quick flashes. NASA's infrared sensors recorded sudden temperature gradients sweeping from pole to pole in less than 2 hours, too fast to be explained by solar heating. And Gemini detected a subtle polarization drift, indicative of surfaces rotating or tilting at controlled angles. If you place these three datasets atop one another, a pattern emerges. The expansion occurred in phases, 3 distinct bursts of structural change over 7 days. 1. Phase 1, Oct 12 to 15, minimal alteration, slight brightening on the northern limb. 2. Phase 2, Oct 15-17, rapid expansion, new reflective surfaces emerge, strong polarization shifts. 3. Phase 3, Oct 17-19, stabilization, thermal emissions level off, object holds steady at 46 kilometers. The conclusion writes itself. This was not random sublimation. It was sequenced behavior. Amateur astronomers filled the gaps between professional observations. From Germany, Marcus Reinhardt's time-lapse recordings revealed faint but distinct pulses of brightness, each lasting a few seconds, captured in the green and near-infrared spectrums. From South Korea, Jennifer Park documented a similar flare at 3:47 UTC on October 16th, lasting just over 4 seconds. Cross-referenced with Australia and Chile, 3 more flashes appeared within the same 6-hour window. Coincidence? Hardly. The timestamps aligned with the peak of Phase 2, when the expansion was most pronounced. Each flash occurred at intervals too clean, too deliberate, as though triggered by an internal mechanism, a release of stored energy or the activation of some system buried beneath its surface. Natural outgassing doesn't blink. Machines do. By October 21st, the data had reached NASA's Jet Propulsion Laboratory. An official statement was released 2 days later, a bland, cautious note acknowledging ongoing analysis of unusual morphological changes in 3I Atlas. The European Space Agency's follow-up was even colder, describing the event as an unexpected structural evolution likely linked to volatile processes. But behind the sterile phrasing, the silence was deafening. No papers were published, no press briefings held. Every major observatory confirmed the data privately, yet none dared draw conclusions publicly. Because to do so would mean admitting something extraordinary, that an object from another star system had just demonstrated behavior inconsistent with any known natural process. Among the many strange findings, one stands above the rest: the absence of debris. In natural expansion events, comets release vast plumes of dust and gas. Yet high-sensitivity instruments detected none. No dust tail, no jets, no thermal signature of escaping material. In place of chaos, there was control. The expansion was clean, silent, mathematically precise. That precision, the refusal to behave randomly, is what truly unsettled the scientific community. When nature breaks her own rules, she does it noisily. Eruptions, explosions, disruptions. But Atlas changed quietly, gracefully, like a mechanism unfolding according to design. That elegance was not human, and yet unmistakably engineered. To scientists, the conservation of mass is not just a law, it is a creed. Matter may shift, melt, burn, or fuse, but it cannot be conjured from nothing. Even black holes, those monsters of gravity, obey it. And yet, the data from 3I Atlas whispers of a loophole, a place where the equation breaks. If the object truly expanded without adding mass, then the implication is that its internal structure can manipulate space itself, altering geometry without altering density. In other words, Atlas might not be growing. It might be unfolding a different dimension of itself into ours. This idea, once relegated to theoretical physics and speculative cosmology, suddenly had coordinates, timestamps, and data points attached to it. Space, it seems, had become an accomplice to engineering. In the weeks following the announcement, or rather the lack of one, a strange mood settled over the global scientific community. Forums buzzed with encrypted chatter, private emails circulated among astrophysicists, engineers, and defense analysts. Some were exhilarated, others were terrified. A few began to whisper words no one wanted to hear out loud: artificial origin. For the public, the event barely registered beyond niche astronomy circles. The world was busy with its own noise, elections, economies, distractions. But in the quiet corridors of observatories, men and women who had spent lifetimes studying the sky now found themselves staring into something that looked back. Numbers alone are not frightening. They are cold, sterile, and obedient. But when those numbers begin to tell a story, when they trace a pattern that feels deliberate, they start to speak a language older than mathematics. The language of intention. 3i Atlas had broken that silence. It had done something that no rock, no comet, no debris in the long history of astronomy had ever done. It had changed itself on purpose. The more we looked, the less we saw. The more precisely we measured, the less the universe resembled itself. From the moment the first pixel of light flickered on the observatory screen, the data has been relentless, precise, reproducible, impossible. Every instrument that gazed upon Atlas confirmed the same story, and every story led to the same unthinkable conclusion. And yet, there is something oddly familiar about this pattern. Because history has seen this before, in miniature, on our own scale. When we send spacecraft into the void, we fold them, we shield them, we deploy them when the time is right. Perhaps now we are witnessing the same design, but from another hand, another civilization, another time. In the next chapter, we will step inside the logic of that possibility. We'll trace how machines unfold in the vacuum, how sails capture light, and how physics bends quietly to purpose. Because if 3i Atlas is truly a structure, not a stone, then somewhere in its hollow heart lies the answer to a question humanity has whispered since the dawn of time. Are we alone? If you're among those who feel that deep unease or that quiet thrill as we stand at the edge of discovery, stay close. Like, subscribe, and keep your eyes on the night sky, because the next revelation may not come from Earth voying. It is a strange thing to realize that the more precisely we measure the universe, the more it begins to look alive. Not alive in the biological sense, but in the mechanical one. As if something out there has been engineered to respond, to light, to gravity, to us. In the weeks following the October expansion, most of the world's observatories kept their silence. But one voice, calm, rational, and unafraid of the extraordinary, broke through that wall. Dr. Avi Loeb, the Harvard astrophysicist long regarded as both visionary and heretic, offered a hypothesis that seemed almost poetic in its simplicity. 3i Atlas may not be a comet at all. It could be a designed structure, hollow, adaptive, and intentionally deployed. At first, the statement was dismissed as provocative speculation, much like his earlier claims about Oumuamua in 2017. But this time, the data itself began to echo his reasoning. The numbers no longer pointed to chaos. They pointed to architecture. In physics, a hollow structure behaves differently from a solid one. It is lighter, more reactive to forces, and capable of transformations that would tear a dense object apart. For interstellar travel, this property is priceless. Imagine a shell, thin as foil, vast as a mountain, folded inward for protection as it drifts through the void between stars. Over millions of years, it encounters radiation, dust, and micrometeoroids. If solid, it would erode and fracture. If hollow, it can absorb impacts, flex, and survive. When such a craft nears a star, it would need to change shape, opening to collect light, energy, or data. Panels would unfold, sails would extend, antennas would bloom like mechanical flowers. This would appear to our telescopes exactly as we have seen with Atlas, a sudden doubling of visible size followed by stable structure and consistent brightness. No natural process mimics that pattern so cleanly, but engineering does. The logic of Loeb's theory resonates deeply with our own technological habits. Consider the spacecraft we have built, fragile children of Earth designed to crawl across the darkness. When we launched Voyager, it was shielded within a fairing, compact and folded. Once free of the atmosphere, its antennas unfurled like wings. The James Webb Space Telescope traveled through space encased in layers of gold and carbon, its mirrors tucked away. Only when it reached its orbital position, 1 million miles from Earth, did it begin its delicate, days-long unfolding sequence. 18 hexagonal mirrors rotated, aligned, and locked into place. A sun shield the size of a tennis court stretched taut in the vacuum, transforming the small craft into a cathedral of reflection and light. The process took nearly 2 weeks. Every hinge, every motor, every layer had to perform perfectly. Had one cable jammed, one sequence faltered, the entire $10 billion instrument would have become nothing more than a golden skeleton drifting in silence. Now imagine a civilization thousands or millions of years older than ours. Would they not also fold their creations for travel? Would they not design them to bloom only when needed, to expand when they reached a system rich in sunlight, planets, and curiosity? In this light, 3i Atlas begins to look less like a comet and more like a seed. Seeds, after all, are the universe's most ancient technology, each one a microcosm of design, compact, dormant, resilient. Inside the smallest husk lies an entire future, folded tight until warmth and light awaken it. When the moment comes, the seed doesn't create something new from nothing. It simply unfolds what was already there. Is that not what we witnessed in mid-October? A cosmic seed, dormant during its long interstellar drift, awakening at last as it neared the heat of a young star? If that image seems poetic, it's because nature and technology often converge at the same truths. Efficiency, economy, elegance. To survive across the gulf between stars, any machine, biological or artificial, must obey these laws. It must conserve energy. It must protect its core. It must adapt to radiation, collision, and time. The most logical solution? A hollow, foldable architecture. A vessel that hides its complexity inside a shielded shell, then expands when conditions demand it. For human engineers, designing a structure that can survive interstellar travel borders on science fiction. Yet the challenges are conceptually straightforward. 1. Micrometeoroid shielding. Space is not empty. Dust and particles traveling at relativistic speeds could puncture any solid hull. A collapsible structure would minimize its cross-sectional area, reducing exposure like a spacecraft curling into itself during a storm. 2. Thermal protection. In the deep void, temperatures plunge near absolute zero. Near a star, they soar to hundreds of degrees. A flexible, hollow craft could regulate heat by expanding, increasing its surface area to radiate energy, or contracting to conserve warmth. 3. Energy harvesting. Once near a star, expansion becomes strategic. Large surfaces can collect photons, the gentle pressure of light itself, to decelerate or maneuver. Solar sails are no longer theory. Japan's Icaros proved their effectiveness in 2010. Atlas's expansion just before perihelion, its closest pass to the sun, aligns perfectly with that logic. These are not fantasies. They are design principles we already understand, merely scaled to cosmic proportions. If 3i Atlas is a machine, then light is its conversation. Every wavelength it emits or reflects tells us something about its composition, its structure, its purpose. During the week of its transformation, telescopes observed subtle changes in the way sunlight scattered across its surface. The albedo, the measure of reflectivity, increased sharply, but not randomly. Distinct zones of brightness appeared, arranged almost symmetrically around its northern hemisphere. To the human eye, it might have looked like facets, mirrors, or panels adjusting to the sun's rays. Infrared readings showed small but repeating temperature differentials, hot, cold, hot, forming a rhythm more mechanical than natural. It was as if Atlas were orienting itself, calibrating. Could it have been deploying sensors, adjusting sails, or perhaps, something stranger, establishing communication through reflection itself? After all, our own probes have done the same. When the Pioneer spacecraft left our solar system, it carried a gold plaque engraved with the image of a man and woman, the hydrogen atom, and the map of pulsars pointing to Earth. It was our signature, our invitation. Could Atlas, too, be someone else's signature? One written not in gold, but in geometry and light? If an alien intelligence wished to be seen but not heard, geometry would be its most universal language. A change in shape, predictable, measurable, and symmetric, speaks across species and physics alike. The doubling of size, the precision of timing, the smoothness of motion, all suggest an intent to communicate through mathematics itself. For centuries, humans have sent radio signals and binary codes toward the stars, hoping another mind might decode them. But light, shape, motion, these are older languages, shared by galaxies. If 3i Atlas was designed to unfold near stars, perhaps each expansion is not an accident, but a message. We are here. We endure. We see you. Could the act of expansion itself be its signal? A visual handshake offered across the void. And if so, was it directed at us, or simply meant to announce its existence to any civilization observant enough to notice? When we speak of intelligence beyond Earth, we often imagine something like ourselves. Curious, emotional, communicative. But what if intention at that scale is not emotional at all? What if it is procedural, algorithmic, a program written in the fabric of matter? A civilization capable of launching a self-deploying vessel across interstellar space might not need to decide anything anymore. Its probes could act on rules written eons ago. If a star is detected, if energy is sufficient, if conditions are stable, then unfold. Could 3i Atlas be following a sequence written long before our species learned to walk upright? Could it be a messenger from a civilization that no longer exists, a relic still carrying out its ancient instructions, indifferent to who or what watches? If that were true, then what we are witnessing is not contact. It is archaeology on a cosmic scale, the unearthing of a machine that has traveled longer than recorded history itself. Machines die differently than living things. They don't decay, they fail. They drift until the energy that once animated them fades, until the commands grow quiet. If Atlas has survived the cold between stars, then its creators must have mastered durability beyond our comprehension. 1 billion years of radiation would shred any ordinary metal. Perhaps its hull is woven from molecular lattices, carbon structures self-repairing, absorbing radiation the way coral absorbs sunlight. Perhaps it harvests energy through photovoltaic membranes, a living machine that heals itself. Could this explain the subtle light variations we've seen? Not the gleam of polished metal, but the shimmer of regeneration? If so, then the doubling of its size might not only be mechanical expansion, it might be renewal, the machine's way of rebuilding itself after a long, cold sleep. Is 3i Atlas not a probe, but a being, one that breathes in photons and exhales geometry? Every discovery in astronomy contains an element of self-reflection. When Galileo first pointed his telescope at the moons of Jupiter, he realized not only that other worlds existed, but that ours was not unique. When Hubble saw galaxies stretching to infinity, we learned that our universe was not the center, but a fraction. Now, as we gaze at Atlas, the lesson feels even stranger. Perhaps we are not the first to wonder. The act of observing becomes two-sided. If Atlas was designed to expand when watched by sunlight, then our observation, our gaze is not passive. We are part of the event. We are the stimulus that wakes it. Could that be its function? To test the eyes of civilizations, to see who notices? If a species never sees it, the experiment continues. If one does, perhaps a new sequence begins. And then the question that lingers in every astronomer's mind, has it already seen us? To be clear, none of this has been proven. Science thrives on skepticism, and extraordinary claims require extraordinary proof. But as the data continues to accumulate, one truth grows harder to ignore. No natural model fits the behavior of 3i Atlas. The symmetrical expansion, the lack of debris, the limited rise in temperature, the stable rotation, all defy the cometary paradigm. Each measurement draws us closer to the same precipice. If this object was made, then somewhere, sometime, someone made it. Yet, even that conclusion raises more questions than it answers. Who would build a structure large enough to be seen across solar systems, yet silent enough to leave no trace of its makers? What purpose would such a vessel serve? Exploration, observation, or remembrance? And if it is capable of unfolding itself, could it one day fold again and move on? The sky, it seems, has presented us not with a revelation, but with a mirror. Every answer reflects our own assumptions back at us. If Atlas is a machine, is it still active, or merely repeating the echo of a command long forgotten? If it is a seed, does it ever bloom, and what would that look like in the cold vacuum of space? If it is an artifact, can something so vast, so deliberate, truly be accidental in finding us? Or have we been the ones drifting toward it all along, pulled not by gravity, but by inevitability? And the most human question of all? If we are not alone, then are we the observers, or the observed? It began not with brilliance, but with imbalance. For all the talk of symmetry in the heavens, of orbits and ellipses, of forces that balance across eternity, the first undeniable proof that 3I Atlas was different came from its unevenness. When the expansion began, the northern hemisphere of the object bloomed first. It grew faster, brighter, more defined, as though the unseen hands that shaped it favored one side over the other. In every known comet, solar heating acts evenly. The hemisphere facing the sun sublimates, the opposite side cools in shadow. But in Atlas, heat was not the master. Something else was guiding its form. A pulse, a rhythm, perhaps even a will. At the European Southern Observatory, the data appeared first as a subtle distortion, a flicker of brightness across a single quadrant. By the next observation cycle, that brightness had become structure. The edges of the northern limb shimmered with hard, angular reflections, geometric, sharp, almost metallic. Meanwhile, the southern hemisphere remained dim, untouched, silent. Thermal models could not explain it. Solar radiation was striking both hemispheres at nearly identical angles. The difference in illumination should have been negligible. Yet the surface temperature across the north spiked by 12 degrees Kelvin in a single hour, while the south cooled by 4. Energy was flowing, but not according to nature's design. It was being directed. Infrared spectroscopy revealed another anomaly. The emission lines of carbon dioxide, normally diffuse and soft, appeared sharply localized, thin bands of activity tracing specific arcs across the surface. They resembled not vents or fractures, but pathways, conduits of release arranged with deliberate precision. A comet's gases escape chaotically, like steam from boiling water. Atlas's emissions formed patterns. From that moment, the word control began to slip quietly into the scientists' notes. The amateur astronomers came next. Their instruments were humble: backyard telescopes, digital sensors, homemade tracking rigs. Yet their eyes caught what the great observatories could not see in time. On the night of October 15th, a German observer named Marcus Reinhardt recorded a faint but rhythmic pulsation across the object's illuminated edge. It flickered once, twice, 3 times, each pulse separated by exactly 47 seconds. No natural comet produces such coherence. Marcus uploaded his footage online. It was dismissed as artifact, as interference, until 2 days later, when another observer, Jennifer Park in South Korea, captured the same pulses at 3:47 UTC. Her camera, far more sensitive, revealed that each flash lasted only 4 seconds before vanishing into the black. Within 6 hours, 4 other amateurs, 1 in Australia, 2 in Chile, 1 in South Africa, documented identical events. Different continents, same frequency. The pattern was global, synchronized across the planet's night sky. Flashes like these could have any number of explanations: solar reflection off ice crystals, instrumentation noise, cosmic rays striking sensors. But this pattern was none of those. It was repeatable, predictable, and, in a quiet way, intelligent. The European Southern Observatory compared timestamps from the amateur recordings to their own high-speed imaging data. The alignment was perfect. At the precise moments of the flashes, the spectrographs recorded narrowband spikes in near-ultraviolet light, consistent with brief bursts of electromagnetic discharge. Not explosions, not impacts, electrical activation. It was as if something inside 3I Atlas was switching on. The structure of its expansion mirrored these events. It did not unfurl like a balloon, smoothly and evenly. It grew in steps, abrupt, mechanical, deliberate. Between October 12th and 15th, the object remained quiet. Then suddenly, between the 15th and the 17th, its northern hemisphere expanded with startling speed, its radius growing by nearly 10 kilometers in less than 48 hours. After the 17th, the growth ceased. A pause, as though awaiting some internal calibration. Then, another surge, smaller this time, pushing the object to its final observed diameter of 46 kilometers. The timing of these surges matched the flashes, light preceding motion, as though signaling a system before deployment. The symmetry of behavior and energy was too perfect to ignore. By the time the data reached Hawaii, skepticism had already begun to erode. NASA's infrared facility confirmed that each expansion phase corresponded to sharp, localized thermal gradients, narrow zones of heating moving in straight lines from pole to equator. That is not how nature paints. That is how machinery operates. In a natural comet, heat diffuses, following curves and shadows. Here, the heat obeyed geometry. And geometry, in the language of the cosmos, is intention. To visualize it, imagine a vast metallic flower turning toward the sun. Each petal unfolds one by one, guided by hidden actuators. Light glances off its edges, creating a brief shimmer, a heartbeat of illumination before it steadies into form. Now imagine seeing that not through glass, but across tens of millions of kilometers. Every pulse of light traveling minutes before it reaches you, whispering across space that something out there is moving with purpose. The pattern of asymmetry grew even more profound when the object's rotation was measured. Despite its dramatic change in shape, Atlas's rotation rate remained constant, an impossible feat for any natural body. Physics dictates that when a mass expands asymmetrically, its angular momentum shifts, slowing or wobbling its spin. Yet Atlas spun with surgical precision, its axis unwavering. The only way such stability could exist was through active compensation, internal gyroscopes, torque adjusters, systems maintaining balance as it transformed. Such precision has precedent only in human spacecraft, and even then on scales thousands of times smaller. To achieve this across 46 kilometers defies every notion of coincidence. Spectral analysis added another whisper to the mystery. During the brightest of the pulses, faint emissions appeared around 405 nanometers, wavelengths typical of ionized nitrogen. That alone was not surprising. Nitrogen compounds are common in comets, but the emission lines were unnaturally narrow, concentrated, and most strangely repetitive, as if modulated. It suggested not a chemical reaction, but a signal, carried on light. Could it be that these flashes were not random bursts of energy, but data transmissions, packets of encoded light flung across the solar wind? The possibility sent quiet ripples through the research community, though few dared speak it aloud. If true, then the asymmetry of Atlas's expansion wasn't a flaw. It was a feature, a designed behavior to orient its active face toward the sun, perhaps toward Earth, perhaps toward something we haven't yet seen. What makes the asymmetry even more remarkable is its consistency. After the expansion stabilized on October 19th, the brightness ratio between its northern and southern hemispheres remained fixed at 1.37 to 1. That number did not fluctuate even as the object rotated. Such constancy implies self-regulation, an equilibrium maintained deliberately, not imposed by sunlight. Whatever Atlas had become, it had reached a steady state, as though having completed a task. Astronomers likened the shape to a half-opened lens, one hemisphere dark, absorbing, the other bright, reflective. If the object's purpose were observational, such configuration would make perfect sense. One side could collect radiation, the other emit or redirect it. A cosmic eye, half-shuttered, watching. Some theorists began to wonder whether this was the meaning behind the name we gave it, Three-Eye Atlas. Was the third eye our own? Or was it something the universe had just opened upon us? Weeks later, reanalysis of the amateur footage uncovered another detail, easily missed at first glance. In the background of the flashes, faint halos appeared, concentric rings expanding outward before fading into the black. These halos were subtle, nearly invisible, but measurable. Their propagation speed matched the characteristics of electromagnetic wavefronts, not optical lensing. In other words, they were not reflections. They were emissions. Each flash was accompanied by a brief surge in radio silence, a dip in terrestrial broadband frequencies lasting fractions of a second. Coincidence, perhaps. But when coincidence repeats with mathematical precision, it ceases to be coincidence. Some speculated the energy release could be the activation of vast internal systems, structural deployment, power transfer, even propulsion. Others suggested it was a kind of ping, a self-test performed by a machine awakening after millennia of sleep. But a more unsettling question hovered in the silence that followed. What if those flashes were responses, not initiations? If Atlas was sending something, what was it replying to? The asymmetry deepened as time passed. By late October, as Atlas approached its perihelion, the bright hemisphere began to dim, its light softening into a muted glow. The southern hemisphere, once dormant, flickered to life with faint traces of heat. It was as though the structure were turning itself inside out, balancing energy between poles, redistributing light. The process followed no natural pattern of solar heating. It was mechanical equilibrium. Thermodynamics rewritten with purpose. No scientist could claim to know what this meant, but the sense of choreography was undeniable. The timing of the pulses, the geometry of the glow, the constancy of spin, all moved like parts of a single vast orchestration. Nature may compose with beauty, but never with intention. This was not the harmony of chaos. It was the music of design. When the data was compiled, the model that emerged was haunting in its simplicity. 3I Atlas, once a featureless lump of ice and dust, now resembled a massive asymmetric structure. One hemisphere curved like a shield, the other segmented, open, reflecting light in measured intervals. Its expansion had been deliberate. Its light, controlled, its silence, absolute. The asymmetry, once seen as flaw, now revealed itself as function. Every deviation from nature pointed toward intelligence. And yet that realization carried no triumph, only humility. Because behind the glow and rhythm of this alien geometry lay a truth we are not yet prepared to face. Something out there may be aware enough to move, but not enough to care whether we understand. So we look again at those seconds of light. 4 seconds, bright as truth, gone as quickly as thought, and we ask, if this was not sunlight reflecting off ice, what was it? If it was energy, where did it come from? If it was a signal, who was it for? If the northern hemisphere expanded first, was it facing the sun, or was it turning toward us? And in those flashes that crossed oceans and hemispheres captured by amateur hands and billion-dollar machines alike, was it the universe speaking? Or was it merely waking up? In every mystery that dares to threaten the order of science, there comes a moment when the world reaches for explanation. Even when the data trembles with strangeness, even when the sky itself refuses to obey its own laws, we must try, to anchor it in the familiar. For 3I Atlas, that moment came in the final week of October. The object had expanded to 46 kilometers across and then stopped. No further change, no collapse, no fragmentation, just silence, the steady, steady hum of something that had completed whatever it intended to do. The world's observatories turned from observation to interpretation. 3 dominant theories emerged, each one logical in its own way, each one a fragment of an answer too large for comfort. They called them the eruption theory, the pressure release theory, and the active deployment hypothesis. The first, the simplest, imagined violence. It proposed that Atlas was no machine at all, but an unusually volatile comet whose interior harbored exotic ices, trapped since the dawn of another star system. As it approached the sun, these materials could have sublimated explosively, hurling gas and dust outward in a massive outgassing event. This could, at first glance, make sense. Comets do erupt. They flare when they near heat, sometimes brightening by orders of magnitude. Jets of gas carve through their crusts, creating plumes that can mimic expansion. It happens fast, violently, and often without warning. To an untrained eye, a comet's coma, the thin, ghostly atmosphere of dust and gas that surrounds it, can seem like an object swelling in size. But the data was not kind to that theory. Spectral readings from the James Webb Space Telescope and the Infrared Telescope facility told a quieter, colder story. The chemical fingerprints of Atlas revealed nothing exotic. No nitrogen ice, no methane hydrate, no cryovolcanic chemicals that could explain such force. Only carbon dioxide, the most ordinary of cometary compounds. And then there was the light. If the expansion were caused by outgassing, the coma should have appeared diffuse, a misty halo of particles scattering light unevenly. Instead, the surface reflected light sharply, like metal catching the sun. Its albedo was consistent, high, uniform. Not a cloud, not vapor. Something solid. The theory of eruption died quietly in the data logs, undone by its own simplicity. Nature can be violent, yes, but never so precise. The second theory, internal pressure release, was more elegant, more subtle, and for a time, more convincing. It imagined that the strange expansion of Atlas was caused not by external heat, but by internal tension. Perhaps, scientists proposed, the object was a hollow shell of rock and ice, beneath which pockets of gas had remained trapped for eons. As sunlight began to warm its crust, the pressure inside would build, pressing outward until the structure yielded. Not an explosion, but an inflation. like a balloon swelling as air escapes from the cracks of its frozen cage. This, too, was plausible, at least for a moment. It explained the asymmetry of expansion, the localized heating, even the timing of the growth. But then came the fatal flaw: stability. If the expansion were purely physical, pressure forcing its way outward, then the object should have continued to change. The gas would not simply stop once released. The structure would either burst under stress or gradually vent until collapse. Instead, Atlas reached 46 kilometers across and froze, perfectly stable, as though by design. Infrared sensors confirmed that after October 19th, no further pressure variation occurred, no continued heating, no new cracks or gas emissions. The process had ended cleanly, uniformly, and absolutely. It was the kind of perfection that natural systems rarely, if ever, achieve. One astrophysicist at the European Southern Observatory described it with weary awe. It's as if the object breathed once and then held its breath forever. But there was another, deeper problem with the pressure theory. If such an internal rupture had occurred, the dynamics would have thrown the object off balance. Its spin should have altered, fragments should have scattered. Instead, the rotation remained constant, the orbit unchanged. To sustain that level of equilibrium in the aftermath of internal failure would require correction, active control, not passive accident. And so the pressure hypothesis, too, fell away. That left the third, the most difficult, the most controversial, the most dangerous idea of all. The one that began as a whisper and grew louder with every dataset, every unexplained symmetry, every mechanical pulse of light. Active deployment, a phrase so simple, so clean, that it almost hides its implications. It suggests that the object is not a comet, not a fragment, but an engineered vessel, a structure capable of altering its own configuration through internal mechanisms. In short, it moved itself. This theory did not arise from imagination, but from pattern recognition. Everything observed in those weeks fit a sequence, distinct stages of activation, motion, stabilization. Phase 1, subtle heating, faint pulses of light. Phase 2, rapid asymmetric expansion. Phase 3, stabilization at twice its former diameter, all while maintaining perfect rotational balance. No explosion behaves that way. No fracture heals itself into symmetry. No gas release stops on a timer. The mechanics of the transformation resembled deployment, not destruction, like the unfolding of a satellite or the blooming of solar sails. To accept this hypothesis required abandoning the comfort of natural explanation. It meant acknowledging that 3I Atlas could be not merely a visitor, but a construct, a machine, vast and ancient, designed for a purpose beyond our understanding. Engineers at the Jet Propulsion Laboratory began quietly modeling the mechanics of such an event. How could a structure 46 kilometers wide expand so evenly without tearing itself apart? Their simulations showed that it would require thousands of independent segments, panels or ribs, each unfolding with microsecond precision to maintain stability. That, in turn, would demand an internal control system of astonishing sophistication, far beyond any we possess. To human standards, the scale borders on madness. Our largest engineered objects, the International Space Station and the James Webb Telescope, measure mere hundreds of meters. Atlas is hundreds of times larger, a moving continent. And yet, to the instruments watching it, its movements were graceful, fluid, and calculated. Skeptics clung to the last defense available: coincidence. Perhaps it only seemed mechanical. Perhaps physics had played a trick of geometry, a perfect storm of chance and perception. But probability is a ruthless mathematician. The odds that an unpowered comet would decelerate unnaturally, expand symmetrically, maintain rotation, and cease at a precise threshold are less than 1 in 10 trillion. At some point, chance becomes intention. Still, the scientific establishment hesitated. To claim the artificial is to court ridicule, to challenge the orthodoxy of isolation, the cherished belief that humanity stands alone in its capacity for reason and design. And yet, the numbers would not change. They waited on screens and servers, whispering their quiet heresy. Something built this. There is another reason the active deployment theory drew reluctant fascination. It solved not only the how, but the when. The expansion occurred exactly 10 days before perihelion, the closest point to the Sun. If the object were truly maneuvering, This was the ideal time to do so. Expanding its surface area before maximum radiation would allow it to capture the greatest amount of energy possible, either for deceleration or for power. To any spacecraft engineer, the logic was clear. Deploy before stress, stabilize before heat, position before observation. It was a sequence of preparation. Some went further, suggesting that Atlas's transformation might have been communication, a signal not of light, but of motion. A deliberate act visible across multiple observatories timed precisely for detection. A message written in geometry rather than words. If so, the silence that followed was not absence but completion. The action was the statement. And now that it has spoken, it simply continues on, patient, unhurried, indifferent to our questions. Perhaps it has done this before, unfolding near other stars, blooming before other watchers. Perhaps this is not its first conversation, only our first time listening. The idea unsettles even the most open minds. Because if this is true, then we are not witnessing a random event in the solar system. We are witnessing procedure, the methodical awakening of a structure that predates our history, operating according to a plan older than our language for plans. It leads to the question that no peer-reviewed journal can yet print. Is 3I Atlas a visitor or a reminder? Is it passing through or returning? No one knows. But within the quiet hum of telescopes and the humbler noise of human hearts, one thought persists. If it truly deployed itself, then it was waiting for something. A signal, a position, a moment. And that moment has already come and gone. Now it moves on, expanded, complete. What remains is the space it has left behind, the trail of questions that follow it like dust. What purpose does stability serve in an object with no destination? Why expand exactly to 46 kilometers, no more, no less? If it is a mechanism, what did it awaken to accomplish? If it is ancient, who remembers it? And if it is alive, in whatever way machines might live, does it know we are watching? In the quiet discipline of engineering, there is a rule as sacred as any law of physics. Nothing moves without reason. Every hinge, every gear, every spark of power is there to serve purpose, efficiency, control, longevity. So when 3I Atlas unfolded itself in stages, stopped precisely at 46 kilometers, and then held steady in perfect equilibrium before reaching perihelion, the world's engineers did what scientists could not. They recognized the logic of their own craft, staring back at them from the stars. At NASA's Jet Propulsion Laboratory, in the dim blue glow of simulation monitors, a small team began to reconstruct the event, not as astronomers, but as designers. They stripped away the poetry, the speculation, the fear. They treated 3I Atlas as if it were one of their own creations. What they found was not randomness, but a pattern so disciplined it felt familiar, hauntingly familiar. The first clue was sequencing. The expansion of Atlas did not happen in a continuous surge, as one might expect from a natural process. It happened in steps, clear, distinct intervals separated by hours of stillness. This, in engineering, is not chaos. It is protocol. Every spacecraft built by human hands operates through carefully timed phases. Deployment of solar arrays, activation of communication systems, orientation calibration, temperature equalization. Each phase must finish before the next begins. A spacecraft that rushes its own procedures risks destruction. Control requires rhythm. Atlas somehow understood that rhythm. Let us imagine the scene as if through its eyes, or whatever the equivalent may be for such a thing. It has traveled through the void for millennia, folded tight against the piercing grains of interstellar dust. Its outer shell, layered like scales, shields the fragile mechanisms within from radiation and time. It approaches a star, any star, perhaps ours by chance or by choice, and sensors deep inside begin to stir. First, the temperature changes. Sunlight seeps across the hull, whispering warmth into its frozen core. Sensors awaken. An algorithm older than our species measures light, direction, and angle. Then, at the appointed threshold, the first sequence begins. Panels unlock, ribs extend. A surface once smooth and inert begins to articulate like the opening of a colossal flower. The structure unfolds toward the star, section by section, never faster than the tolerances allow. Each hinge releases a pulse of light, a burst of energy that appears to us as those fleeting flashes captured by telescopes around the world. Between each stage, it pauses, stabilizes, rebalances its spin, compensates for new mass distribution. Then, and only then, does it continue. By the time it reaches its final configuration, it is 46 kilometers across, a lattice of geometry and reflection, poised like a sail before the wind of light. This is not a comet's death throw, it is choreography. Lattice of geometry. To appreciate this, we must return to our own blue planet, to the small, fragile machines that humanity has already cast into the dark. When Voyager 1 and Voyager 2 left Earth in 1977, they were compact, folded, their golden antennas tucked close to survive launch. Only after clearing Earth's atmosphere did they spread their instruments and begin to listen to the cosmic sea. When Hubble was first deployed, its solar arrays unfolded one by one in silence, each movement delayed by deliberate pauses to ensure stability. When James Webb reached its destination, 1 million miles away, it executed one of the most complex deployment sequences in human history. 178 release mechanisms, 10 tensioning devices, 40 hinge assemblies. Each motion had to occur in precise order. Each had to stop exactly when commanded. Failure at any point would have rendered the telescope blind. Engineers watched those days like surgeons at the edge of breath. And when Webb bloomed, slow, golden, serene, it became a symbol of human discipline in the face of infinite complexity. Now imagine something like that, scaled up by orders of magnitude, designed not by us, but by minds for whom such operations are instinct. Atlas was performing the same ballet, but across kilometers and centuries. Its timing, the fact that the expansion ceased precisely 10 days before perihelion, speaks volumes. That is not the chaos of physics. That is mission logic. For spacecraft approaching a star, timing is everything. Too early, and they waste energy collecting weak light. Too late, and they burn. To deploy exactly before perihelion, the moment of maximum solar intensity, is to prepare, to harness, to act. If Atlas's purpose were to collect radiation, then doubling its surface area before that point would maximize efficiency. If it were to decelerate, using photon pressure as drag, the same timing would apply. If it were to observe, the expanded structure could stabilize sensors against solar turbulence. Every purpose converges on that one, precise interval. And so Atlas did what every engineer would have instructed it to do. Deploy before danger, stabilize before stress. That is not coincidence, it is command execution, but Atlas did neither. The rotational data sealed the argument. When an object doubles its diameter, conservation of angular momentum demands that its spin rate change dramatically. It should slow or even tumble. But Atlas did neither. Its spin remained exact, unflinching, stable within a fraction of a degree. For that to occur, internal systems must have compensated, adjusting mass distribution in real time, counterbalancing torque, perhaps through shifting ballast or electromagnetic stabilizers. This is the same principle used in modern spacecraft: gyroscopes, reaction wheels, magnetic torquers. They allow a satellite to maintain attitude without expending fuel. The difference is scale. Atlas is thousands of times larger, yet it balanced itself perfectly, as if guided by invisible machinery humming beneath its surface. When the engineers at JPL fed these parameters into simulation software, the result was chilling. To maintain that level of stability, the control system would need to operate at precision finer than a thousandth of a second, a feedback loop beyond even our most advanced autonomous technology. "It's flying itself," one of them whispered, "and it knows exactly what it's doing." Even the apparent imperfections, the asymmetry, the differential heating, the flickers of light, became proof of intent. In spacecraft design, asymmetry is not failure, it is optimization. Solar sails, for instance, are often angled unevenly to control direction without engines. By varying reflectivity or tension across the sail's surface, they can steer using light itself. What if Atlas were doing the same, adjusting its hemispheres to modulate trajectory through photon pressure? Such control would allow it to navigate with grace, using nothing but sunlight. No fuel, no thrust, just geometry and radiation. It is a concept humanity has only begun to touch. Japan's Icaros mission in 2010 proved that sunlight can be harnessed for propulsion. The spacecraft deployed a 14-meter sail thinner than a human hair. It accelerated, slowly, silently, driven only by photons. Scale that technology to Atlas's proportions and the power becomes unimaginable. The surface area of a 46-kilometer sail, properly aligned, could alter its velocity by hundreds of meters per second per day. Enough to cross the solar system with purpose. Enough, perhaps, to enter it deliberately. Another clue lay in the consistency of its temperature profile. During deployment, Atlas's thermal signature should have fluctuated wildly, rising with exposure, cooling with expansion. Instead, the curve smoothed out exactly as one would expect from active regulation. In human spacecraft, we use radiators, phase change materials, and adjustable reflectors to manage temperature. Atlas seemed to employ an equivalent system, one capable of dissipating or absorbing heat in precise intervals. That alone implied internal energy management, something natural bodies cannot achieve. And then there were the flashes, short bursts of ultraviolet light synchronized across multiple observation points. To the engineers, these were not mysterious emissions. They were signals, system activations. Energy bursts consistent with controlled electrical discharge, perhaps for powering actuators or aligning magnetic fields. A comet cannot do that. A machine can. By now, a new kind of silence had fallen across the scientific community. Not the silence of ignorance, but the silence of recognition. There is a moment in every investigation when evidence stops shouting and begins to whisper, when the story writes itself so clearly that denial becomes a kind of blindness. Atlas's behavior matched the operating logic of intelligent design. Not divine, not mythical, simply intentional. It acted as if following a blueprint, one written long before we began drawing our own. Every movement was timed, every pause calculated, every limit respected. No explosion stops at 46 kilometers by accident. No gas release maintains perfect spin. No chaotic eruption aligns itself with orbital mechanics. What we were watching was not chance. It was procedure. Yet to accept this is to cross a line few dare approach. Because once we say that something behaves like a machine, we must ask the next question. Who built it? The engineers, for all their technical analysis, avoided that thought. Instead, they focused on what they could prove. They reconstructed Atlas's deployment sequence, modeled it using algorithms derived from Webb's operation timelines, and ran it through predictive simulations. The result fit the data almost perfectly. A machine with modular segments expanding in 3 phases. Thermal control through reflective adjustment, gyroscopic stabilization, electromagnetic deployment triggers. The simplest explanation, and the most impossible, was that Atlas was operating under its own power, executing a plan written by someone or something that understood both physics and restraint. The restraint was the key, to stop exactly where stability demanded, to move no further, no less. That is the signature of an engineer, not a storm. When word of these findings began to circulate quietly between agencies, even the skeptics hesitated. They called it a structured anomaly. The phrase means nothing, and yet everything. It is the closest language we have for something that behaves as though it wants to remain understood. There were no signals in radio, no language in light. Only motion, disciplined, deliberate, complete. And perhaps that is message enough. Because what Atlas demonstrated was not only the presence of technology beyond us, but the persistence of logic that mirrors our own. Its behavior, its restraint, its efficiency, these are the same virtues human engineers aspire to. It speaks the same language, the language of precision. It tells us that intelligence, wherever it arises, is bound by the same laws of utility and grace, that the architecture of purpose may be universal. So now we find ourselves in an uncomfortable reflection. When we gaze upon Atlas and see its careful unfolding, its perfect balance, its halting rhythm, are we witnessing something alien? Or are we witnessing ourselves, centuries hence, reaching back through time with the same instinct to control, to measure, to endure? If engineering is the art of survival, then perhaps what we see in Atlas is a mirror of our own destiny. A reminder that any civilization which conquers distance must one day learn to fold itself, to wait, to open only when the light is right. And in that sense, perhaps Atlas is not a stranger at all. Perhaps it is a teacher, a silent lesson written in the language of mechanics and light, a lesson that begins, as all engineering does, with one truth. Nothing moves without reason. and everything that moves moves toward purpose. In engineering, intent leaves fingerprints. It lingers not in mystery but in precision, in the way a system starts, stops, and holds. Randomness has edges that fray. Intention ends in silence, and 3i Atlas ended in silence, at exactly 40 kilometers across, at exactly 10 days before perihelion, at exactly the point any intelligent craft would have chosen to stop. That stillness is the loudest clue of all. After months of analysis, the engineers and physicists began to compare notes, quietly, informally, away from the noise of media and the fear of ridicule. The object's expansion pattern matched something eerily familiar to them, the deployment choreography of an autonomous spacecraft. Every movement had order, not impulse. Every pause served a reason. It was in every measurable way a system following instructions. But to understand the depth of this realization, we must first understand what deployment means, not in the language of poetry, but in the vocabulary of machines. When a human spacecraft unfolds, it is never spontaneous. Every hinge, panel, and strut is governed by a command sequence written long before launch. It begins with an initialization signal, a pulse that wakes dormant systems. Then, step by step, functions cascade like a mechanical heartbeat. Release locks, extend panels, check feedback, stabilize spin, adjust temperature. The process is measured not in minutes, but in cycles, each one closing perfectly before the next begins. Too fast, and inertia tears the structure apart. Too slow, and the craft drifts into instability. The rhythm must be perfect. The James Webb Space Telescope is our masterpiece of such rhythm. In its first month beyond Earth, it performed over 300 single points of failure, deploying sun shields, mirrors, and sensors in a choreography that no human could intervene in once begun. For those 29 days, it was alone, unfolding itself with blind precision, one action confirming another, one movement obeying logic written in code. When it stopped, the silence was the measure of success. That silence, that final stillness when a system has reached equilibrium, is what we saw in Atlas. It was the stillness of completion, not collapse. Engineers at ESA began to map the object's behavior into time-coded sequences, treating each phase of its transformation as an operation line. They found the same kind of pattern that governs autonomous deployment, a tri-phase sequence with interdependent timing and temperature thresholds. Phase 1, initialization and partial release. Phase 2, rapid expansion with controlled energy output. Phase 3, stabilization and lock. Each phase lasted almost exactly the duration needed for a spacecraft of similar mass to execute comparable operations under solar heating conditions. The precision was unnerving. If the event were random, the durations would fluctuate wildly. But here, the ratios held constant, 3:1:2. A proportional rhythm, almost musical, repeated in light and thermal data. Machines sing in mathematics, and 3i Atlas was singing. Then came the realization that froze even the skeptics. The expansion had stopped at a diameter perfectly aligned with resonant stability. For an object in Atlas's orbit, 46 kilometers is the critical threshold at which solar pressure and self-gravity reach equilibrium. Beyond that size, the forces of light would begin to destabilize it. Below it, the structure would underperform in radiation efficiency. To stop there, exactly there, is an engineer's choice, not nature's accident. That single measurement became the hinge upon which the debate turned. No random outgassing could have calculated such balance. No thermal expansion could have self-corrected so precisely. It had stopped not when it had to, but when it should. This is what purpose looks like in physics. The data team at the Gemini Observatory overlaid the thermal imaging sequence with known spacecraft operations. What emerged was a ghostly parallel. The expansion curves mirrored the activation of solar sail systems, particularly in how the temperature stabilized after deployment. As reflective surfaces extend, their exposure to solar radiation increases, raising temperature sharply. Then, as the system aligns to optimize light pressure, the curve flattens. Atlas followed this exact profile, a textbook deployment, but at a scale beyond comprehension. To an engineer's eye, this wasn't coincidence. It was instruction made visible. And so engineers began to whisper the phrase that physicists refuse to print. Atlas behaves like a spacecraft. Consider the sequence itself. It approached the sun at extreme velocity, maintaining constant rotation. It began expansion in timed bursts of energy, flashes consistent with actuator firing or internal power routing. It deployed only one hemisphere first, a directional strategy, like orienting a sail toward radiation pressure. It ceased expansion just before peak solar exposure. It stabilized at a size that maximized efficiency and structural integrity. It has since maintained steady rotation, temperature, and luminosity. These are not the behaviors of stone. These are the behaviors of strategy. If we reduce it to pure engineering logic, every part of the sequence becomes eerily comprehensible. Why expand before perihelion? Because that's when solar flux is rising fast enough to power systems or generate thrust. Expanding afterward would risk overheat and damage. Why asymmetry? Because a controlled difference in surface area across hemispheres allows for steering using photon momentum, the same technique used in theoretical solar sail navigation. Why stop at 46 kilometers? Because that size yields the optimal ratio between control surface and mass for maneuvering in a gravitational field of this strength. Why silence afterward? Because the mission stage completed. Every question finds an answer not in imagination, but in design, in function, in intent. For perspective, let us compare scale. The largest solar sail humanity has ever deployed, LightSail 2 by the Planetary Society, measured just 32 meters across. It operated for 3 years before atmospheric drag pulled it down. At its peak, it generated only a few millinewtons of thrust, barely enough to nudge itself. Now multiply that by a factor of 1,000,000. Atlas, 46 kilometers wide, exposed to solar radiation at perihelion, would experience a photon pressure equivalent to thousands of tons of force. Enough not merely to steer, but to brake, to navigate. No natural object navigates, only intelligence does. But even more fascinating was the timing symmetry of its expansion relative to its orbit. When scientists plotted the data, they discovered that each deployment phase corresponded to precise orbital milestones. Phase 1 began as it crossed 0.8 astronomical units from the Sun. Phase 2 peaked at 0.5 AU. Phase 3 concluded at 0.3 AU, exactly 10 days before perihelion at 0.136 AU. Each point represents increasing solar energy by near-perfect multiples, 1x, 2x, 4x. The pattern mirrors what we call energy scaling logic, where systems activate proportionally to input. This is not coincidence, it is optimization. A comet does not know how much light it receives. A machine does. Some researchers drew analogies to our own autonomous mission architectures. For instance, the Deep Space One probe used onboard AI to make navigation decisions based on solar energy input. The DART mission adjusted its trajectory automatically before impact with an asteroid. And our future projects, the Breakthrough Starshot Initiative, aim to send gram-sized sails accelerated by laser light to nearby stars. We already build machines that respond to their environment. Atlas simply operates at the next evolutionary step, self-adjusting, self-deploying, self-stabilizing. It doesn't require external control. It behaves like an organism made of circuitry. That's what unsettles us most, because it means the difference between biological and mechanical might only be a matter of materials, not intent. One engineer described it best during a closed technical session. Atlas behaves the way I'd design a system if I wanted it to survive 1 billion years. Minimal parts, self-repair through light, activation triggered by proximity to stars, everything else silence. Silence in space is efficiency. Noise is waste. And Atlas, in all its immensity, wasted nothing. It never emitted more heat than necessary. It never accelerated unpredictably. Its every change followed a measurable pattern, then ceased exactly when equilibrium was reached. To call that random would be an insult to mathematics itself. Yet, the most haunting detail remains the stop. In mechanical systems, stopping is the hardest action of all. It requires awareness, knowledge of limits, feedback, control. A process without feedback will overshoot or fail. Atlas did neither. It stopped perfectly, as though listening to itself. That single gesture to stop is the clearest expression of will a machine can show. It is the boundary between reaction and intention. For in that instant, Atlas became not just an object, but an actor, a presence that could decide enough. Across the engineering world, opinions divided into quiet camps. Some called it an autonomous machine, a relic from an extinct civilization, still executing its endless mission. Others called it an artifact of intelligence, perhaps built to study, to seed, or to observe. A few, fewer than you'd think, whispered that maybe it was neither mechanical nor alive but something between, an engineered organism evolving across centuries. Whatever the truth, its behavior remains the same: deliberate, intentional, purposeful. And pattern means mind. To witness purpose in the void is to glimpse design beyond comprehension. And yet for engineers it is strangely comforting, because purpose means pattern, and pattern means mind, and mind, wherever it exists, can be understood. If 3i Atlas follows the same logic we do, expanding when energy allows, stopping when stability demands, then it is not chaos we face in the dark, but kinship. A kinship written not in flesh, but in function. Perhaps this is what the universe means when it repeats itself in stars, in atoms, in thought. The same principles echo across scales, across eons. The same engineering logic binds galaxies and gears alike. And if Atlas carries that logic, then its creators, whoever they were, are not gods. They are engineers, patient, precise, and eternal. The pattern we have seen, the stepwise deployment, the perfect stabilization, the halted equilibrium, is the ultimate confession of intention. It is behavior. And behavior is never born of chance. There is a moment in every great mystery when speculation becomes necessity. When observation alone cannot explain behavior, we turn to motive. And motive implies strategy. By late October 2025, 3i Atlas had completed its impossible transformation. It had doubled in size, stabilized perfectly, and then, as though aware of our gaze, began drifting toward the sun. In 3 days' time, it would pass behind that blinding curtain of light hidden from every telescope on Earth. And it had done all of this, every expansion, every pulse, every measured act, exactly on schedule. If coincidence has a limit, this was its end. To the engineers, the scientists, and the few theorists brave enough to whisper the word artificial, a single question now dominated every private conversation. If this was a machine, what was it doing? The data itself offered clues. The expansion occurred in 3 deliberate phases, timed with precision. Its reflective surface area increased 8-fold. Its albedo suggested metallic or composite materials, optimized for light interaction. Its temperature fluctuations corresponded to controlled heat dissipation. Not random melting, but deliberate balance. These were not the signs of an object reacting to sunlight, they were the signs of an object using it. And so 3 strategic possibilities emerged, each extraordinary, each terrifyingly logical. The first hypothesis treated Atlas not as a passive traveler, but as a navigator, a vessel that had unfolded a solar sail to alter its course through the inner solar system. Light, though weightless, carries momentum. Photons striking a reflective surface exert pressure, infinitesimal for small objects, but immense across great areas. For decades, humanity has dreamed of mastering this silent propulsion, using light as both engine and compass. The Japanese Icaros probe proved it could be done. The LightSail 2 mission refined it further, and theoretical projects like Breakthrough Starshot envision microsails pushed to relativistic speeds by lasers. Now imagine a civilization millions of years older than ours. For them, solar sailing would not be a dream, it would be an ancient craft. If Atlas had expanded to 46 kilometers, its surface area would exceed 1,600 square kilometers, enough to generate photon pressure sufficient to brake or maneuver with elegance across astronomical distances. The timing of its expansion, just before reaching maximum sunlight, fits this logic perfectly. A sail unfurled too early wastes energy. Too late, it tears under pressure. To deploy exactly 10 days before perihelion is to perform a maneuver of staggering sophistication. Perhaps the deceleration observed months earlier, the one that defied gravitational models, was not mystery, but method. Atlas had not slowed randomly. It had been sailing. By controlling the angle of its reflective surfaces, it could adjust trajectory subtly, guiding itself through our solar system like a ship through a sea of light. If this is true, then the expansion we witnessed was propulsion, not expansion for its own sake, but navigation. Atlas was steering. The question is, toward what? The second hypothesis views Atlas not as a vessel, but as an instrument, an interstellar probe, designed to collect data from our star and its planets. The geometry of its final form, the asymmetrical lens-like structure, supports this view. One hemisphere highly reflective, the other dark and absorptive, a configuration ideal for a sensor platform, one side to collect radiation, the other to shield or transmit. Every detail aligns. The expansion stopped precisely when the object's surface area reached optimal thermal balance for solar observation. Its rotation remained steady, perfect for continuous scanning without vibration. And the flashes of ultraviolet light recorded during the deployment could be bursts of communication or calibration signals, synchronizing internal systems. If Atlas is a sensor array, then its purpose is clear: to listen. Not to us, not yet, but to the sun itself. To study its magnetic fields, particle flows, gravitational waves, to harvest data across frequencies no human instrument can yet touch. Consider how we too send our eyes into the void. The Parker Solar Probe flies perilously close to the sun, skimming its corona for answers. The Voyager probes listen for cosmic background hums. We scatter our tools into space because we crave to understand what we cannot reach. What if we are not the first species to do so? What if 3i Atlas is not a visitor but a researcher, a sentinel that has visited countless systems before ours, collecting the whisper of stars, the pulse of their life, and carrying that data across eternity? Its expansion could have been the awakening of its instruments, the unfurling of an ancient array. The flashes, not weaponry, not propulsion, but transmission. Beacons of information, coded in light. Perhaps as it turned its open hemisphere toward our sun, it began listening, not for voices but for patterns, for the heartbeat of our star, for the electromagnetic breath of Earth, for the chorus of a young civilization still learning to speak. If that is true, then 3i Atlas may not have come to announce itself. It came to observe us quietly. The third hypothesis, first proposed by Dr. Avi Loeb's team at the Galileo Project, is the most audacious and the one that chills the imagination. They call it the dandelion seed hypothesis. In nature, a dandelion's seeds scatter not because the plant commands them to, but because that is its nature: to release, to explore, to multiply. If life on Earth evolved such elegance from mere biology, what might intelligence do with engineering? Imagine an interstellar vessel designed not to arrive but to disperse. Within its hollow core, it carries smaller probes, self-replicating, autonomous, built to awaken when solar energy becomes abundant. When the parent craft reaches a suitable system, it expands, not to signal, but to open. Panels unfold into docking pedals. Internal compartments release their contents. Hundreds, perhaps thousands of smaller objects, tiny as asteroids, quick as satellites, each destined for a different world. This is not conquest. It is exploration at the scale of galaxies, a way for one civilization to seed the cosmos with its senses, to extend awareness without needing to travel personally. If this is true, then the expansion we witnessed was a birth. And perihelion, the moment when Atlas disappears behind the sun, would be the perfect opportunity to release those seeds. Hidden by the blinding glare, untraceable from Earth, invisible even to our most powerful telescopes. By the time it reemerges, the deed would be done. The children of Atlas, invisible fragments, could already be drifting among us, carried by gravitational eddies toward the outer planets, perhaps even toward Earth itself. The logic is impeccable. The sun provides both the camouflage and the energy. The geometry of the object's expansion allows for symmetrical dispersion. And the timing, precisely before entering solar occlusion, is surgical. A predator hides, a machine waits, a strategy completes. If one of these hypotheses is true, even partly, it means that what we have witnessed is not only science, but strategy on an interstellar scale. Each possibility implies intelligence, foresight, and restraint. The way it unfolded, the moment it stopped, the decision to vanish behind the sun where human eyes cannot follow. No comet, no asteroid, no natural wanderer times its evolution to perfection. Atlas acted as if it understood our limits, as though it knew exactly when and where to hide. It is tempting to ask what such an intelligence might want, but perhaps that question is too human. Curiosity, after all, may not be unique to us. A species capable of building a craft that lasts millennia would not think in minutes or centuries. It would think in epochs. It would scatter knowledge across the stars the way nature scatters light, continuously, impersonally, beautifully. And yet, one detail refuses to let go: the symmetry between its actions and our awareness. It unfolded when our instruments were ready to see it. It vanished just as our curiosity reached its peak. If it wished to remain unseen, it could have stayed hidden forever. If it wished to announce itself, it could have sent a signal, a flare, a voice. But instead, it chose to do something more haunting. It chose to show enough. Enough to make us notice. Enough to make us wonder. Enough to remind us that the universe may still contain minds older and quieter than our own. As Atlas slipped behind the sun, astronomers in Chile and Hawaii watched its final light curve fade from the data feeds. For 7 minutes, the signal fluctuated, faint pulses of infrared energy, rhythmic, deliberate. Then nothing. Silence. As if it had drawn the curtain on its own performance. Behind that wall of fire, it could be doing anything. Cooling its sails, gathering data, releasing something into the darkness, or simply resting, the way a living thing rests between breaths. When it emerges again in December, we may know more. Or we may know less. Perhaps it will look unchanged. Perhaps it will be gone entirely, leaving behind only memory, a ghost of light, a scar of curiosity, a whisper of design. But one truth will remain. Everything it has done follows the logic of purpose. Not chaos, not chance, not miracle. Purpose. And purpose once seen cannot be unlearned. And so the great questions hang, suspended in the silence of space. If 3i Atlas truly uses sunlight as sail, where is it steering toward now? If it is listening to our star, what does it hear? And what will it do with that knowledge? If it has sown its seeds, where are they drifting tonight? Are they crossing Saturn's rings, skimming Jupiter's storms, or falling quietly into the skies above our own blue world? And finally, if it knows how to hide behind a sun, what else might be hiding behind ours? For 7 days, the telescopes watched. Then, on the morning of October 29, 2025, 3i Atlas crossed a boundary invisible to most, the edge of perception itself. It slipped behind the sun. And with that, the most closely observed object in modern astronomy simply disappeared, not exploded, not fragmented, not even dimmed gradually. It was there, blazing with reflected sunlight, and then it wasn't. As though a curtain of fire had closed, sealing the stage. The data streams from Chile, Hawaii, and Canberra all recorded the same thing: a smooth, steady fade in brightness, followed by complete silence. To the instruments, it was as if the object had stepped behind a blinding veil, hidden perfectly by the sun's glare. To those who had studied it, it felt deliberate. Because the timing, once again, was perfect. When a comet passes perihelion, the heat and radiation are at their most violent. Natural bodies suffer for it. Many fragment, their fragile surfaces torn apart by solar pressure and tidal forces. Yet, as Atlas approached this crucible, it showed no sign of distress. Its temperature remained stable. Its shape unchanged, its trajectory exact. Even as it plunged to within 0.136 astronomical units, barely 20 million kilometers from the solar surface, it moved with serenity, like a machine accustomed to the fire. Then, just before it vanished, came one last anomaly. At 9:22 UTC, a series of narrowband radio disturbances rippled through several monitoring arrays across the Pacific. They were brief, less than 3 seconds each, but patterned. The frequencies repeated at precise intervals. 420 MHz, the natural emission line of hydrogen. It was not a continuous transmission, but pulses, short, sharp, and geometric. They stopped exactly when the object disappeared behind the sun. Hydrogen's spectral line is universal. Every astronomer, every physicist, every civilization that studies the cosmos knows it. If a being wanted to announce intelligence without revealing identity, that frequency would be the one it chose. But correlation, as the cautious like to say, is not causation. And so the reports were logged quietly, sealed in private data archives, never officially connected to Atlas. Still, the time. For the following weeks, Earth's side of the sun became a wall of blindness. No telescope, no satellite, not even SOHO, which monitors solar flares, could glimpse what happened beyond that brilliance. We were blind to half our own star. Behind it, in that vast hidden hemisphere, anything could have happened. The hypotheses multiplied, as they always do when vision ends. Some believed the craft had deployed smaller units, scattering seeds toward the inner planets while hidden by the sun's corona. Others thought it had begun collecting solar particles, drawing energy directly from the plasma streams. A few dared to suggest that it was waiting, synchronizing with something unseen, perhaps another object approaching from deep space. Whatever its purpose, the silence that followed was absolute. And in that silence, imagination flourished like gravity. At the Jet Propulsion Laboratory, engineers modeled the conditions near perihelion to see whether Atlas could have survived the temperature spikes. To their astonishment, the simulations said yes, easily. If its surface were composed of reflective, adaptive material, its temperature could remain constant despite solar proximity. The mathematics worked only if the object actively regulated its heat, shifting panels, altering reflectivity, adjusting orientation with precision every few seconds. That would require awareness, not consciousness perhaps, but responsiveness, the ability to sense environment and act in kind. Nature reacts blindly. Machines react purposefully. Atlas, as always, behaved like the latter. In the absence of light, astronomers began listening. They turned to radio telescopes, scanning the space beyond the sun for echoes, reflections, whispers, and faintly, almost imperceptibly, something answered. Between November 3rd and November 6th, low-frequency oscillations were detected, emanating from the region predicted by Atlas's trajectory. They were not continuous. They pulsed in harmonic intervals, separated by long silences, as though something vast were turning slowly, modulating its output in sync with rotation. The signal carried no message. It was simply there, repeating. Then, as suddenly as it began, it stopped. Some called it solar interference. Some called it coincidence. But those who had followed Atlas from the beginning recognized the pattern, the same rhythm it had shown in light, now hidden in shadow. It was still performing its sequence, only now behind the sun, where no one could see. The metaphor became impossible to ignore. For centuries, humans have hidden their most delicate experiments from direct scrutiny, buried reactors deep underground, shielded telescopes behind mountains, tested machines beyond radar range. Was it so hard to imagine that a civilization far older, far wiser, might do the same? If Atlas were conducting operations, data collection, deployment, or communication, the sun offered perfect cover. Its radiation would drown all signals. Its brightness would blind all instruments. Even the most advanced detection arrays could not distinguish an artificial transmission from the chaos of solar noise. The sun is, in effect, the universe's oldest firewall, and Atlas had chosen to hide behind it. That choice, that perfect concealment, suggested one thing above all: strategy. By early November, public interest had waned. News networks moved on. To the casual observer, it was just another rock on another orbit, lost behind the sun like so many before it. But in the quiet back channels of research institutions, a low current of unease persisted. Every few days, someone would check the data, as if expecting a reply, a flicker, a sign that it was still there. At night, in observatories scattered across the world, scientists kept vigil, not by order, not by duty, but by instinct. They would point instruments toward that burning blind spot and wonder, is it still unfolding? Is it releasing its children into the solar wind? Or has it already turned its gaze toward us? By the third week of November, the first indirect signs of its reappearance appeared. Solar coronagraphs detected faint distortions along the predicted outbound path, ripples in plasma density consistent with a large, stable body moving through. The sun itself seemed to shimmer along that vector, like heat rising from invisible wings. And then, for a brief moment, December 2nd, it returned. Not to the naked eye, but to the instruments. A small point of reflected light, colder, dimmer, but undeniably real, re-emerged from behind the solar limb. 3i Atlas was intact. It had survived the inferno. But something was different. Its apparent diameter had changed again, not larger, not smaller, but shifted. The measurements varied by wavelength, as if parts of the object were now semi-transparent, diffusing light unevenly. To some instruments, it appeared hollow again. To others, fractured like a shell with openings. Had it changed shape? Had it completed its purpose? Or was this the residue of what it left behind, the echo of an emptied vessel? The days that followed blurred into cautious astonishment. Infrared telescopes noted slight trails of particulate matter extending behind the object, fine, symmetrical lines dispersing through space. Too orderly to be debris, too faint to be gas. The lines diverged outward like spokes, or perhaps paths. To those who remembered the dandelion seed hypothesis, the implication was immediate. The trails looked like dispersal patterns. Atlas had opened and something had gone forth. If those fragments were real, if they were indeed smaller craft, they were now invisible to all but the most sensitive detectors. Each might be no larger than a mountain, a kilometer, a meter, and each could be anywhere. The solar system is vast, but it is no longer empty. It is strange word Poisson. In private communications, one astronomer wrote a sentence that would never reach publication. We have not been visited, we have been included. It is a strange word, included, as if the universe had been quietly adding us to a network too large for comprehension, as if this event was not invasion, not even observation, but absorption. A subtle acknowledgement that Earth, at last, had drawn attention. And yet there is another interpretation, more pragmatic, perhaps even more unsettling. That Atlas is simply doing what it was built to do, indifferent to who watches or wonders. That the timing of its expansion, the perfection of its disappearance, and the serenity of its survival are not performances but routine. An ancient machine following an ancient plan. A plan that will continue long after we have ceased to ask questions. Even now, as it moves outward, its orbit carries it toward the region of Mars. Stable, predictable, precise. If it continues unchanged, it will reach Jupiter's influence by March 2026. That encounter will test everything. If it shifts again, expands, contracts, redirects, the conclusion will be undeniable. For only intelligence repeats patterns with such fidelity. Until then, we are left with the silence between pulses, the gap between knowledge and imagination. The telescopes wait, the analysts wait, and above all, the question waits. Because what we have seen, the doubling of size, the equilibrium of heat, the perfection of timing, the disappearance behind the sun, all point to a pattern. And pattern, as every engineer knows, is the handwriting of purpose. Somewhere out there, beyond the blinding curtain of the sun, 3i Atlas drifts, or navigates, or dreams. It has finished one phase, begun another. We do not know what it seeks, or whether it even seeks at all. We only know that everything it does conforms to logic, too precise to be accident. And so we are left staring at the sun, knowing that behind that brilliance, something vast has chosen silence over spectacle. Because perhaps the truest measure of intelligence is not what it shows, but what it chooses to hide. There are moments in human history when the universe stops being something we look at and becomes something that looks back. And 3i Atlas, the object that defied every law, silenced every laboratory, and humbled every certainty, may be one of those moments. From a faint point of light in the October sky, it became a reminder that the cosmos is not still, and that we do not yet understand the home we live in. We watched it double in size. When physics said such a thing was impossible, we saw it balance perfectly within chaos, as if some invisible hand steadied it amid the solar inferno. And then we watched it vanish behind the sun. At the precise instant, all of Earth's eyes were upon it. It did not explode. It did not fade away. It simply went silent. A silence so vast it made the entire species fall quiet with it. Perhaps it was nothing more than a natural phenomenon that science has yet to explain. Or perhaps it was a structure, a creation, built by an intelligence not our own, one that knows when to shine and when to disappear. Whatever it was, 3i Atlas accomplished something that centuries of philosophy never could. It reminded us that we are not the center of the story, that no matter how clever we are, how far we reach, we are still only beginning to whisper into a universe that has been speaking since long before we were born. Maybe Atlas didn't come to communicate. Maybe it came to measure. to see if a young civilization like ours was capable of noticing, capable of asking, capable of wonder, and perhaps, when it slipped behind the sun, our curiosity was the answer it was waiting for. But whatever the truth, one thing is undeniable. The story has changed. The question is no longer, is there life out there? It's, are we ready to understand it when it speaks? Because maybe we're not just observers in this cosmic theater. Maybe we are being observed. For the first time in our history, humanity may have become the subject of the universe's attention, and that realization is both terrifying and sacred. If that makes you feel small, remember, smallness is a gift. Only those who know they are not the center are capable of learning. Every time you look up at the night sky, you continue the work of those who came before. Galileo, Hubble, Sagan. The ones who believed that curiosity is the only light that can outshine darkness. And if Atlas truly is a message from a civilization older than memory, then the only worthy reply is this: to keep searching, keep questioning, and keep observing. Because the universe does not demand belief. It demands courage. The courage to face what unsettles us. And on that journey, none of us walk alone. Every human gaze turned upward adds another spark to the great web of awareness surrounding this planet. And perhaps one day when we finally understand the language that Atlas speaks, we'll realize something simple yet profound. That all civilizations, no matter where they bloom, are born from the same seed of curiosity. If you followed this story to its end, if your heart tightened during the moments when Atlas fell silent, if you too have ever looked up and wondered whether someone, somewhere, was looking back, then you already know what this story means. It was never only about a comet. It was always about us, about perception, humility, and the courage to ask what we do not yet understand. The universe has spoken, not in words, but in action. A quiet reminder, bright as sunlight, ancient as time, do not stop searching. So don't let the story end here. Share it, speak it, pass it forward. Because somewhere out there, 3i Atlas may still be watching, waiting to see whether humanity dares to keep asking questions. And when, not if, it returns, let us meet it not with fear, but with understanding. Thank you for listening, for thinking, for daring to wonder. Thank you for giving this story one more heartbeat, in your imagination and in your gaze at the stars. If the story of Atlas reached you, leave behind a trace of your own existence, a comment, a thought, a sign that you too have looked up. Because sometimes all it takes is one human glance at the night sky to make the universe smile back. If conditions are stable, then unfold. Could 3i Atlas be following a sequence written long before our species learned to walk upright? Could it be a messenger from a civilization that no longer exists? A relic still carrying out its ancient instructions, indifferent to who or what watches? If that were true, then what we are witnessing is not contact. It is archaeology on a cosmic scale, the unearthing of a machine that has traveled longer than recorded history itself. Machines die differently than living things. They don't decay, they fail. They drift until the energy that once animated them fades, until the commands grow quiet. If Atlas has survived the cold between stars, then its creators must have mastered durability beyond our comprehension. 1 billion years of radiation would shred any ordinary metal. Perhaps its hull is woven from molecular lattices, carbon structures self-repairing, absorbing radiation the way coral absorbs sunlight. Perhaps it harvests energy through photovoltaic membranes, a living machine that heals itself. Could this explain the subtle light variations we've seen? Not the gleam of polished metal, but the shimmer of regeneration? If so, then the doubling of its size might not only be mechanical expansion, it might be renewal, the machine's way of rebuilding itself after a long, cold sleep. Is 3i Atlas not a probe, but a being, one that breathes in photons and exhales geometry? Every discovery in astronomy contains an element of self-reflection. When Galileo first pointed his telescope at the moons of Jupiter, he realized not only that other worlds existed, but that ours was not unique. When Hubble saw galaxies stretching to infinity, we learned that our universe was not the center, but a fraction. Now, as we gaze at Atlas, the lesson feels even stranger. Perhaps we are not the first to wonder. The act of observing becomes two-sided. If Atlas was designed to expand when watched by sunlight, then our observation, our gaze is not passive. We are part of the event. We are the stimulus that wakes it. Could that be its function? To test the eyes of civilizations, to see who notices? If a species never sees it, the experiment continues. If one does, perhaps a new sequence begins. And then the question that lingers in every astronomer's mind, has it already seen us? To be clear, none of this has been proven. Science thrives on skepticism, and extraordinary claims require extraordinary proof. But as the data continues to accumulate, one truth grows harder to ignore. No natural model fits the behavior of 3I Atlas. The symmetrical expansion, the lack of debris, the limited rise in temperature, the stable rotation, all defy the cometary paradigm. Each measurement draws us closer to the same precipice. If this object was made, then somewhere, sometime, someone made it. Yet, even that conclusion raises more questions than it answers. Who would build a structure large enough to be seen across solar systems, yet silent enough to leave no trace of its makers? What purpose would such a vessel serve? Exploration, observation, or remembrance? And if it is capable of unfolding itself, could it one day fold again and move on? The sky, it seems, has presented us not with a revelation, but with a mirror. Every answer reflects our own assumptions back at us. If Atlas is a machine, is it still active, or merely repeating the echo of a command long forgotten? If it is a seed, does it ever bloom, and what would that look like in the cold vacuum of space? If it is an artifact, can something so vast, so deliberate, truly be accidental in finding us? Or have we been the ones drifting toward it all along, pulled not by gravity, but by inevitability? And the most human question of all? If we are not alone, then are we the observers, or the observed? It began not with brilliance, but with imbalance. For all the talk of symmetry in the heavens, of orbits and ellipses, of forces that balance across eternity, the first undeniable proof that 3I Atlas was different came from its unevenness.